Hey, I am in my backyard and it is sunset. I'm going to wait until dark, but what I'd like to do is use the dark to do a demonstration of the seasons. So I have a 1000 watt light bulb set up and I'm going to show it to you here in the twilight. There it is, 1000 watts, and it's inside this translucent globe. And that's going to represent the sun. And then over here is a globe representing the Earth. This is not the scale. Earth is about 100 times smaller than the sun, but this will work for showing why the seasons happen. If you've ever noticed a globe, how often the stand on the globe has this tilt to it, that tilt is the 23.5-degree tilt of the Earth's equator relative to the orbit of the Earth around the sun. And you may also have noticed sometimes on globes that little figure 8 symbol or diagram. It's called an analemma, and it is also related to the seasons. But we're going to wait until dark, and we're going to act out the seasons with the help of the sun off in the distance there. Okay, you are looking from the viewpoint of the sun towards the Earth. And the date is December 21st. This view is showing the Earth from the side. There's the sun over there. And here's the side view. So we're seeing the nighttime side and the daytime side of the Earth. The camera is in the position of first quarter moon. And so we're seeing really a third quarter Earth. But what I want you to notice right now is that the southern hemisphere is tilted towards the sun. And the South Pole, which is down here, doesn't matter. As the Earth rotates, the South Pole is forever in the light. 24 hours a day, it's in the light. Whereas the North Pole here, there is no sunlight at all. And the entire Arctic Circle is in darkness 24 hours a day. The Antarctic Circle is in the daylight 24 hours a day. So this is December 21st. This is the winter solstice for the northern hemisphere and summer solstice for the southern hemisphere. What we're going to do now is I'm going to move the Earth 3 months into the future. Here we are. It is March 21st. This is the equinox, the spring equinox for the northern hemisphere, the fall equinox for the southern hemisphere. You can see that the terminator, the line between the daytime side and the nighttime side of the Earth, is running straight through the poles as the Earth rotates. The sun is directly over the equator of the Earth. From the viewpoint from the sun, it's not that any hemisphere is tilted towards or away from the sun. Rather, the axis of the Earth is pointed sideways. Next, we're going to move another 3 months into the future. Here we are again, the side view. The axis is still pointing in that same direction, but now that direction, the North Pole, is now tilted towards the sun, not away from the sun. And so as the Earth spins, the North Pole of the Earth is 24 hours a day in the sunlight. The South Pole of the Earth is 24 hours a day in the darkness. The sunlight is beating down more directly, that is more vertically, onto the northern hemisphere for people in the southern hemisphere that get daylight, but the sun is not as high in the sky. One more time, 3 months into the future. And here we are again. The axis is tilted down my driveway. Axis has not changed direction at all. But from the viewpoint of the sun, the axis is not pointed towards or away from the sun, but rather it's sideways.